All right, in this video, we're going to calculate the inverse function and understand what inverses are exactly. The definition is simply they're functions that undo each other. They're kind of like opposites. That's not 100% accurate, but it's kind of what they are. So let's look at an example. F of x equals 1/2 x minus 7. So the first thing you need to know, the notation for inverse is an F. It looks like a raised to the -1 symbol, and usually x. And this just means inverse of the function f. So when you see that raised to the -1, there's no math happening there. It's just a symbol. So the inverse of this function is 2x plus 14. We'll talk in a minute exactly how we can come up with that. The next thing we want to do is we want to graph both of these functions on the same plane. All right, so I went ahead and graphed that first equation, y equals 1/2 x minus 7. And I did that because it's in slope-intercept form, so I started at the point -7, and I rose 1 and ran 2 to get all of those points. 2x plus 14 is a little bit tougher to graph that way since 14 is the y-intercept and it's way off the grid. So instead, I'm going to make a t-chart. You have to do a little bit of trial and error here. So for instance, you can't plug in 0 for x because you're going to end up getting 14 for y, and that's way off the grid. And really any positive numbers, that's going to happen. So we kind of skip down a little bit. -3 times 2 plus 14 would give us 8. So that does show up on the grid, and we can kind of start and move our way down from there. All right, so there's some points we can go ahead and graph for this function. We want to graph as many points as possible. All right, so there's our two graphs, and I'm going to go and connect the dots. You should both be diagonal lines. I'm just going to go and use the same color. Doesn't really matter. Ooh, ran off a little bit there. A couple things I want you to see. First off, it's a little tricky to see, but you can kind of see how they're approaching each other. They're going to intersect each other right about this diagonal line right here, which, as you'll notice as we get closer to the origin, what this line is y equals x. It's a line that goes right through 0, 0 and has a slope of 1. And this is the line of symmetry for inverse functions. So you can kind of think if we were able to fold this upon that dotted line, these two graphs would fold onto each other. This should sort of make sense because if inverse functions are functions that undo each other, then that makes sense that when you kind of compose these functions upon each other, you end up with just x. All the numbers end up getting canceled out, and you're left with just a plain variable. Second thing that I want you to notice is really the only point that we wrote down for the first equation was the point 0, -7. That was our y-intercept. Well, for the other graph, the x-intercept is the point -7, 0. And in fact, that's going to be true about any of the points we pick. So for instance, let's see the point -6, 2 is on this line. And on the other side, we have this point right here. The coordinates are 2, -6. So the xy coordinates are reversed for inverse functions. So really that's the second and really the third important thing we've talked about here with inverses. There's the symbol for inverses. So I'll go ahead and box that. We talked about the line of symmetry is the line y equals x. So all three of those facts about inverses you need to know. All right, finally, we're going to look at a composition of inverse functions. So composition is what we talked about in the last section. But we just said these are functions that undo each other when composed upon each other. So we saw it graphically, how their line of symmetry was the line of x. So now we're going to see it using composition. Do you remember that? open circles the composition symbol. So we're going to compose the g function into the f function. So this means we're going to take x and substitute it in for g, and that doesn't really change anything. And let's actually, instead of saying f of g, let's say f of f inverse. It doesn't really matter, but since we didn't use the letter g in this example, so we're going to do f of f inverse. So that means we're going to go work our way inside out. We're going to take x and first substitute it in for the inverse function. Of course, nothing changes because it was always already written with an x in it. So this is kind of our halfway answer. And we're now going to take 2x plus 14 and we're going to substitute it in for the f function. So the f function was originally 1/2 x minus 7, but now it's going to become 1/2 times 2x plus 14 minus 7. And pretty simple math here is going to yield our final answer. Distribute the 1/2. So that's going to become 1x plus 7 minus 7, and the 7's of course cancel, and we're left with x. I want you to practice doing the composition of functions the other direction. So now what I want you to do is I want you to take the inverse, f inverse of the original function. Or in other words, I want you to simplify this problem right here. F inverse of f. So pause the video, and I'll show the answer here in just a second. So 1/2 x minus 7 is the halfway. So when we substitute 1/2 x minus 7 in for the original function, probably guess what's going to happen is everything cancels out by the x. And this is the test for inverses. And this is the final rule that we just talked about that you need to know.